The highlights of today's defense news, 11th of September 25. Navy commissions 6th BP tug Sabal into service. Esri India Dhruva Space Inc. pact for easy access to Earth images from 200 satellites. Hindustan Aeronautics signs pact with ISRO InSpace and NSIL to mass produce SSLV technology. Indian Army's AI innovation boosts target detection, secures patent. Tata Advanced Systems and Indra commission first Lanza Naval-3D air surveillance radar system for Indian Navy. In the global highlights from the DSEI exhibition, K3 Scout USV sets a new standard in naval surveillance operations. British Mars autonomous naval drone integrated into combined operations with sensors and loitering munitions. SG-1 Fathom underwater glider enhances undersea surveillance with extended autonomy. Swiss company Destinus conceives Hornet interceptor system to defeat swarms and low-cost drones. In the other global highlights, Australia to roll out fleet of underwater attack drones called Ghost Shark. Japan, UK, and Italy team up on next generation fighter sensors and communication. Canada partners with Germany on critical minerals. HII and Shield AI in partnership to advance drone autonomy software. A look at the news in detail. Indian Navy inducted its sixth 25-ton bollard pull tugboat Sabal at the naval dockyard in Vishakhapatnam. Sabal is the final vessel in a series of 6 tugs built under a contract awarded to Titagarh Rail Systems, Kolkata on 12th of November 21. The vessels are intended to support naval operations by assisting warships and submarines in berthing, unberthing, and maneuvering in restricted waters. They are also equipped to provide afloat firefighting assistance to ships at anchorage or alongside berths. Esri India has signed a memorandum of understanding with Hyderabad-based Dhruva Space to integrate satellite imagery from over 200 Earth observation satellites into its ArcGIS platform. Through this strategic partnership, Dhruva Space will leverage Esri India's advanced ArcGIS technology to enhance its AstraView commercial satellite imagery service that aggregates data from a constellation network of more than 200 satellites spanning optical, SAR, RF, and hyperspectral sensors into a unified ecosystem. The satellite data made accessible through the Esri India Dhruva Space partnership holds transformative potential across multiple domains. In defense and strategic intelligence, it enables real time border surveillance, maritime domain awareness, and precision mission planning by integrating high resolution imagery and multi sensor inputs. Hindustan Aeronautics in InSpace, New Space Limited, and ISRO have signed the agreement for transferring the technology of the Small Satellite Launch Vehicle SSLV in Bangalore. The SSLV technology is a 3-stage vehicle designed to launch satellites weighing less than 500 kilograms into the lower Earth orbit. Under the signed contract, HAL will absorb the technology in the first 2 years, followed by a 10-year production phase. The agreement further grants HAL a non-exclusive, non-transferable license to the technology, including comprehensive design, manufacturing, quality control, integration, launch operations, post-flight analysis documentation, as well as training and support. The Aeronautics and Aerospace Company will also bear the responsibility to mass produce the SSLV technology to meet Indian and global demands. Indian Army has secured a patent for its in-house innovation Automatic Target Classifying System based on artificial intelligence. A cutting-edge technology developed by Colonel Kuldeep Yadav will autonomously identify and classify targets on radar, eliminating the need for human intervention. An AI-powered technology, Automatic Target Classifying System uses sensors and algorithms to detect and identify specific objects or targets from real-time data like images or radar signals by comparing them to a database of stored information. Compared to human interventions, the automatic target classifying system delivers superior speed and accuracy, making it especially valuable in missile guidance and other disposable applications. Notably, 2 years back, Colonel Kuldeep Yadav's another artificial intelligence driven solution, AI powered accident prevention system, had also secured a patent meant to enhance road safety and mitigate accidents. Tata Advanced Systems and Indra commissioned the first Lanza Naval 3D air surveillance radar system for the Navy. The first 3D air surveillance radar, Lanza N, the naval variant of Indra's Lanza 3D radar, one of the most advanced long-range air defense and anti-missile radars, is now commissioned aboard an Indian Navy warship. Following the first commissioning, additional radar systems are being installed across Indian Navy frigates, destroyers, and aircraft carriers. The milestone showcases Indian and Spanish defense collaboration in delivering state of the art air surveillance radar systems. The radar has been seamlessly integrated with all systems of this Navy warship. Its acceptance and induction followed rigorous sea trials during which various naval and aerial platforms were deployed to test performance across a range of radar cross sections. To support ongoing production, a radar assembly, integration, and testing facility has already been established at the Tata Advanced System facility in Karnataka, which will accelerate deliveries. A word about Lanza N. Indra's Lanza N is one of the most advanced long-range three-dimensional tactical surveillance system capable of detecting friendly and hostile air and surface targets within a particular coverage space. The radar is highly effective in detecting various types of drones, supersonic fighters, and anti-radiation missiles, as well as all types of naval platforms. This is the first time that a Lanza N radar would be operational outside Spain. Now, some news about the DSEI 25 exhibition. Kraken Technologies Group presents its uncrewed surface vessel K3 Scout with both dynamic and static demonstrations conducted in cooperation with the UK Ministry of Defence. Based in Fareham, Kraken Technology develops uncrewed naval systems. Already in use with the UK Ministry of Defence and several allied nations, the K3 Scout is considered the company's flagship system. Measuring 8 meters in length, the vessel reaches a maximum speed of 55 knots, carries a payload of 600 kilograms, and covers up to 650 nautical miles. Its modular design allows adaptation to different mission profiles, making it a flexible system suited to current operational requirements. Subsea Craft presents Mars, an uncrewed naval system designed to meet the demands of today's and tomorrow's contested environments. The acronym stands for Autonomous Maritime Disruption for the Modern Battle Space. Mars is introduced as a versatile platform capable of operating beyond the usual range and risk thresholds associated with manned assets. Developed, designed, and launched in only 100 days, Mars illustrates an industrial approach prioritizing speed of execution and adaptability. Its modular structure allows deployment from medium to large surface platforms already in service, which reduces the need for additional infrastructure. Built with a low signature profile and designed for high speed operations, Mars provides a means to conduct missions across a spectrum of scenarios where traditional vessels are either unsuitable or too exposed. Helsing unveiled the SG-1 Fathom, an autonomous underwater glider designed to strengthen surveillance and protection of strategic maritime areas. The SG-1 Fathom is notable for its ability to patrol underwater for up to 3 months without interruption. Designed to operate in conjunction with the LURA platform, it contributes to the creation of a mobile constellation of underwater sensors. This system follows a model inspired by surveillance satellites but adapted to the maritime environment. Each glider transmits its data in near real time, enabling continuous monitoring of potential threats and the early detection of submarines or hostile vessels. From an operational perspective, SG-1 Fathom offers an alternative to anti-submarine warfare missions traditionally carried out by manned patrol aircraft. According to Helsing, this method of surveillance represents about 10% of the cost of conventional approaches while expanding the coverage area. The deployment of the SG-1 reinforces maritime presence in sensitive regions like North Sea, Baltic, and the Atlantic without requiring large human resources. Its ability to operate persistently, discreetly, and autonomously makes it suitable for continuous detection scenarios, particularly in areas surrounding critical infrastructure or vital maritime transit zones. Each unit can be deployed individually or integrated into a fleet of gliders to create a wider network. This network can be managed from a maritime command center by a single operator, significantly reducing manpower requirements and simplifying operational control. Feedback from each mission is integrated into the system, allowing for progressive performance improvements and rapid adaptation to evolving threats. Australia is set to significantly strengthen its naval capabilities with the development of a fleet of advanced underwater strike drones called Ghost Shark under a $1.1 billion defense program. The country will build dozens of these extra large autonomous drones for the Royal Australian Navy, with the first unit expected to enter service as early as January 26. The defense contract has been awarded to Anduril Australia, which will be responsible for building, maintaining, and further developing the Ghost Shark fleet. The new undersea drones are expected to complement Australia's future nuclear powered submarines, which are being acquired through the trilateral AUKUS security pact with the United States and United Kingdom. Defense firms from Japan, UK, and Italy have formed a consortium to design and develop the sensing and communication systems for the Global Combat Air Program (GCAP), a next generation combat aircraft project. The consortium includes Mitsubishi Electric for Japan, Leonardo UK for the UK, and Leonardo and ELT Group for Italy. Named GCAP Electronics Evolution, the consortium is preparing to receive a contract from Edgewing, a joint venture of BAE Systems, Leonardo Italy, and Japan Aircraft Industrial Enhancement. Edgewing will serve as the lead system integrator for GCAP. Under the initiative, the companies will deliver the integrated sensing and non-kinetic effects and integrated communication systems and associated support services. ISANC and ICS will be the main sensing and communication systems for GCAP, designed to integrate and process large volumes of operational data. GCAP Electronics Evolution's leadership team will be based in Reading, South East England, near the GCAP International Government Organization for coordination with the three national ministries of defense and Edgewing. Under the consortium initiative, the partners will continue to leverage the expertise and resources of each participating country through deepening trilateral cooperation to enhance security across Europe and Asia Pacific for decades to come. That's the news for today. We hope you have enjoyed the news. Please do subscribe to our channel and do give us your feedback. Thank you.